Hi, welcome to IMS 2025 here in San Francisco. I'm Daniel Ford. We have a couple of demos set up from a high-frequency module out of MIDI circuits. Here we have a smart variable gain 18 to 43.5 gigahertz variable gain amplifier. This is geared more towards 5G over-the-air testing as well as SATCOM band testing. Here on display we have MIDI circuits integrated GUI showing how you could vary the gain control. And we have it on display here where you could see the gain changing and it stays flat with frequency. You could also save this to memory. This way when you go to turn it on again, it stays at the same gain level. You could also monitor output power with respect to a given frequency, internal temperature. This module also has muting and unmuting features for low power dissipation modes. In this demonstration, we have one of MIDI circuit signal generators producing a 7.9 gigahertz tone to drive a ×3 active multiplier. This has all MIDI circuits content with an HPT gas-based driver amplifier, which inherently has lower additive phase noise when compared to PHEMS. This is ideal for driving the LO of a mixer.
I'm demoing today the ISM and RF Energy products from MIDI circuits. We're showing all of our high power generators in the ISM band and high power combiners. Here is a demo system of using one of our 50-watt RF Energy products. You can see here that embedded in the firmware is S11 sweeps. We can find the optimal power and tune the frequency to match the load. Here we have some coffee beans. Set the power, turn the RF on, and soon enough we'll see some roasted coffee. If we could turn our attention to this area, we have 2.45 gigahertz, 250 watts to 6 kilowatts, 915 megahertz, 800 watts, and an exciting new prototype for 6 to 7 gigahertz at 800 watts. Our waveguide combiners are an innovative patent-pending approach. They're very exciting to a lot of RF Energy generator suppliers. So if we look here, we can see that the beans are starting to heat up, and using the thermal imaging camera, we can see the beans heating up here.
MIDI circuits booth with the microceramics technology. So this year we're just showing off some of the ultra high stop band rejection technologies, which we started with the BFHK years ago, and now we're expanding that to low frequency and high frequency stuff, meaning low pass, high pass. So we're doing low pass filters now, high pass filters, in addition to the classic band pass filters that we've done before. And so here we have a demo just showcasing some of that performance improvement. So for example, here we have one of the older LFCNs, which is the core of the business that we've done for many, many years. And we can see our typical rejection around 50 dB, which is very standard of that technology. When we switch over to something like the LFHK 1575 Plus, we can start to see that now we have rejections that go sub 90 dB of rejection, limited by the noise floor of your measurement tool. However, this technology requires a strip line launch, so not your typical coplanar waveguide or your microstrip lines that you do on the actual face of the PCB. It requires embedding the transmission line within the PCB with ground planes on either side. That's something that some people are just not able to do because they're trying to integrate the design into something that is already existing. So we introduced the interposer models, which end in I, with the BFHK Is. We have those available, and they will be available for the LFHKI and HFHKI as well. And so when we switch to those, just showcasing one of the LFHKIs here, we can see that there's a bit of a sacrifice in rejection. However, you're still getting 10 plus dB over the classic technology in that 1008K style. That's very characteristic of the LFHKs and HFHKs moving forward.
I'm Lee Whiting. I'm looking after MIDI Circuits Test Solutions product line here. On display today, we've got a complete range of our new portable test equipment. With an example demo showing you how easy it is to automate all these things in Python or any other programming language you might choose to use. So the focus today is our new dual channel low cost signal sources. So this is the X-band model, 8 to 12.5 gigahertz. capable of CW, pulsed outputs, and some analog modulation. We're using this in conjunction with our new high-performance 18 gig peak power sensor, mechanical switch box, and then the rest of the range of mini circuits, cables, couplers, accessories, filter and amplifier as example DUTs. So with all of these items, they have USB and Ethernet control. We can integrate them, and then the example on screen here is a simple Python program we've written. So it can sweep frequency, sweep power, synchronize the signal generator and the power sensor, and then on screen we've plotted the amplifier gain, return loss, and even the amplifier P1 dB point by sweeping the power level. Another thing we can show is we can set the two channels of the signal generator to 2 tones, 1 meg, 5 meg apart, and you can use that to do a simple IP3 intermod test with a single dual channel signal generator. And we've borrowed a spectrum analyzer here so you can see the intermod display of the screen there. We have everything from these benchtop modules to the larger rack mounted chassis. So in these chassis we can fit any combination of mechanical switches or integrated test solution according to your needs. Thanks very much for listening.